Hi, everyone. Thanks for attending our session. The session here, just to remind everyone, is Improving Read Replica Performance and Utilization for Amazon RDS. Now, I purposely titled it this way because for those who are using RDS, particularly Postgres and MySQL, they would understand this type of terminology. But if you're using some other databases, this may be something sort of new for you. So it allows me to get a targeted an audience. What I've scheduled here is, what I'm going to do is talk about the concept of a database proxy. And what that database proxy does is it does a bunch of SQL manipulation, query, performance improvement so that the application developer or DBA is offloaded from doing this work. And we're up here on the slide here, just to start off, I provide some database proxy vendors, which I would recommend. We have on my left, your right, Proxy SQL. Has anyone ever heard of Proxy SQL? It's an open source database proxy that is particularly for MySQL. There's MariaDB MaxScale. That's also a database proxy for MySQL. There's also ScaleArc. And then lastly, there's Heimdal Data, which I'm part of. What you'll see here is there are some common features such as connection pooling, read-write splitting, and then there's some differentiation. What I want to focus on are a couple of these features, but what makes Heimdal unique, which may interest you, is that we are database vendor neutral. We do support RDS and any flavor of RDS, and we support automated caching and invalidation. That's the very notable feature that we have that would differ from the other database proxies. However, all of these database proxies I would personally recommend if you choose to deploy one. Now, a little bit about Heimdal Data real quick. We're an advanced technology partner of AWS with competency in data and analytics. Our product is defined as a database proxy. Some people call it a SQL traffic manager. And the idea is very simple. This database proxy improves read-write SQL performance and reliability. And what makes it very interesting is the last bullet. Deployment requires 0 application changes. It requires no changes to your database, no changes to your application, and it's transparent. The way that we achieve this type of transparency is in the following way. On my right, your left side, this database proxy runs as an agent. It runs as a separate process, either on the application instance itself, the EC2 instance, or as a separate central proxy tier, which is hosted as an EC2 instance. It can support any of the SQL flavors of MySQL, Postgres, SQL Server. And if you're using a JVM, we can also act as a JDBC driver, a jar file, that you would insert in between your application and your current vendor JDBC driver. So again, all of these do not require any application changes. What you're doing is you're just directing the application to the proxy, database proxy, and the proxy will talk to the database. Now let's go over a few features that may be interesting for an RDS deployment. The first three, the first row, tends to be very popular amongst RDS users. The first one is query caching on the top left corner. What we can do is that we can automatically cache query results to the cache of your choice. The database proxy is not selling cache. Heimdal Data isn't selling cache. What we're doing is we're providing the cache logic. You choose the cache of your choice or the storage of your choice. That could be Amazon Elasticache, it could be Hazelcast, it could be Gemfire, Oracle coherence, whatever you want, and you direct the database proxy to it, and we start populating it with cache results. And there's some algorithms that we do that we figure out that based on the query variability and the frequency, and if it provides a performance benefit, we'll cache into it, okay? The second feature would be read-write splitting. And that's what we do is and I'll get to it in another slide, is that we can, because we're SQL aware, we can automatically route the write query to the write instance and the read queries to your read replicas. That's what's often called as read-write splitting. We also support connection pooling and connection multiplexing as well. The second row are maybe some features that may interest you. Batch processing is more for Redshift deployment. If you have a lot of singleton DML operations, we can transparently batch them together and send them over to your data source as a single transaction. We also support persistent connection failover. So if your connection or your database instance is unhealthy, we can persist the front-end connection and gracefully fail over to the standby connection. And then lastly, we support some really good SQL analytics, client-side and server-side analytics. But the focus of this discussion, we're going to focus on read-write splitting and caching. And this diagram here is a deployment. If you were to download a database proxy from the AWS Marketplace, you just install it as a separate EC2 instance in between your application and RDS. Very simple. No code changes, no database changes. All these proxies would be managed by a central console. That's centralized mode, but there's another type of deployment which is called distributed mode. This is where the proxies would reside on each application instance. So in this case, there would not be a central EC2 tier, so you would avoid that network hop or network latency, if you will. You can treat the proxy as part of the application. And that one proxy would be doing read-write split and automated caching together. I want to share with you a customer success story. One of our customers, movietimes.com, they're a global online ticketing system with over 1 million users. Their challenge is that they had database overload, and it was too costly for them to build a caching subsystem. So they read one of our blogs in AWS, and they chose Heimdal because with one click, they can enable query results caching. And they were able to diagnose and cure SQL bottlenecks with our analytics. The benefit through our caching was that they were able to increase database scalability 10 times. They saved a couple of developer resources, and they deployed a cache subsystem in 1 day versus 1 year. 1 day versus 365 days. So this was a great success story from a customer. I'm going to go through go down a level deeper on how we implement read-write splitting and caching. What we do here is because we're SQL aware, when we see the query request come through, we know that the writes should go to the write instances and the reads go to the read replicas. So we're automating this process so you don't have to bake this into your application code, and you don't have to modify your code every time you add a write instance or add a read instance. What we're doing here is we're going to not only route the queries to the write master and the read replicas, but we're also going to load balance across the read replicas. So if any of the read replica instances are down, we're going to be able to do a failover. Now, does anyone know what the challenges are of an architecture like this, which is a breaking out your reads and writes. What's the number one challenge of this when you do this? That is correct, both of you. Data sync and replication. The problem here is that if you have a quick read followed by a write, that read may be stale. That data may be stale because the write wasn't replicated to the reads yet, okay? So what we have is lag detection. So that when a read happens followed by a write, and we calculate the time a read happens and the replication has happened to the read replicas, if it falls within that window, which we call the lag detection, that read will not come from the read replicas, but we're going to route it to the write master to ensure that you have fresh data. Does that make sense? So it solves the sync issue or the lag issue or the replication issue. Okay? Any questions so far about read-write splitting and how we do that? Yes? Yeah, so the question is there, can you pretty much ensure or guarantee that that will happen? Mathematically, it's high up there. What we do is we constantly ping the write and the reads to make that calculation. And we have a lag window and we put some slop to it such that we know the behavior of the write and the read, the replication, such that we're quite confident. Now, so basically that's the answer. So the question was, does a Heimdal database proxy handle the replication? And the answer is no. The replication is a database issue. It's a back-end issue, and that's something that Postgres, MySQL, or Oracle, you guys would handle. We do the front-end work of failover, the query routing, and the caching. We don't do the replication. Question? The question is, can we do retries? We can do retries. That's configurable. Okay. Everything is configurable on our GUI. It's all point and click. It's regex configurations. It's very, very simple. Okay. Yeah. So we calculate. The way that we handle the calculate the lag is we calculate the time it takes for the database to write and then for the read to come back. Okay, and that's the lag. Yes, and we incorporate that. We incorporate that. All right? Yes? So the question is for caching. Let's just put it in a caching context. What if an application doesn't go through Heimdal? How would you handle invalidations? And how about if it directly writes to the database? Well, ideally, what you want to do is you want to create a database perimeter that for any application access any database access would go through Heimdal. So we see everything. So we provide all the benefits of caching, but also the analytics. But if someone says, yes, but there's just certain situations that there's applications that's not going to go through a database proxy, okay? So what we do is there are a few solutions. You can create a service that writes to our console to inform us that there was an update to the table. There's database triggers as well that we will poll, and so that we will know that there is a change, and we'll do the invalidation to the cache. Now I want to talk about query caching. What you're going to find here, before I get into it, is that Elasticache is very central to read-write splitting and caching. Elasticache not only serves as the cache, but it also serves as the communication by which the proxies talk to each other, such that if there is an update to the table, the proxies will talk to each other and say, invalidate that entry or invalidate that cache, okay? And it's also how the lag detection is calculated. So when you begin to scale out the proxies, Elasticache becomes a very important component to query caching and read-write splitting. Now, I think I've addressed a lot about the query caching, but I'll get a little bit more in detail about the beauty of this solution. Not only that it's transparent, but what we do is we go through some learning algorithms. And what we're going to do is we're going to look at the query frequency and the query variability. In other words, if there's a lot of duplicate queries, and this query doesn't change much, and number 3, which is important, it provides a performance benefit, then we're going to cache the results. So for example, number 3, I think you understand a duplicate query. I think you understand that queries don't change much. Then it's a good candidate for it being cached. But the third one, how do we measure whether or not it's going to be a performance benefit? Well, we do have some algorithms that look at the latency. If the latency is going to be faster going to RDS as opposed to cache, then we're not going to cache it. Also, you're never going to have a cache miss into Elasticache. We keep track of what's in Elasticache such that we're never going to go into Elasticache to retrieve the results if it's not there. That would be deadly in terms of latency. There's a cache miss into Elasticache, and then you go into RDS to retrieve the data. Okay. The question is, why don't you write your own cache? So here's the benefit of this proxy is that we use Elasticache because obviously we are Heimdal's very tight AWS partners. But in theory, if Elasticache is not serving your needs, we are grid cache vendor neutral. So you could support Redis Enterprise, you could support Hazelcast, Pivotal Gemfire, Oracle Coherence. You can plug and play whatever type of grid cache you want based on your performance needs and management needs, okay? So it's not only Elasticache. And additionally, it can also be local memory. So if you have a large enough application EC2 instance memory, you can cache into that. So a little bit under the hood, we actually provide a 2-tier caching type of scenario where we cache the hot objects in memory, and the remaining, as an L2 cache, it would go into Elasticache. So I think I talked just putting it all together in this type of scenario whereby we see query caching and read-write splitting really go hand in hand with Elasticache, and it provides a great benefit for RDS. Again, the benefit here is improved response times, application response times, improved database scale, and with caching, you would lower your RDS bill, which tends to be a large portion of your AWS line item. Now I'm going to go into a quick demo in the final minutes. For installation and configuration, what's really nice, if you went to the marketplace and downloaded our central console, we have an AWS wizard. So if your Elasticache and your AWS components are defined as roles, we're going to auto-detect your AWS components, and it's just a drop-down menu. You just point our proxy to your various components, and you're done. It's just really nice. We take you step by step, just configuring it, and it's not very complicated at all for configuration. You would install it in minutes, and you can get it up and running very quickly. So what I have here is the console that you see here. Okay. And let's see if it's running here. Let me get some Wi-Fi here. As I'm getting that going, okay. So what I have here is an application called Odoo. This is a Postgres-based application. And I'm going to show you how simple it is. It's basically literally one click. And it's going to be this first button here. By clicking this button, you're enabling caching. There's no more complicated selecting of particular queries to cache. So as an app developer or a DBA, you need to determine which queries to cache, results to cache. You have to set the TTL, the expiry, none of that anymore. So caching can get quite risky and dangerous because you want to avoid stale cache. You click that one button and our learning algorithms start caching the results, and we'll handle all the invalidation. It's automatically invalidated. And the dashboard here for this application, believe it or not, is up in the high 90s in the cache hit rate, okay? What this implies here is only 10% of the traffic is hitting Amazon RDS. 90% of the SQL is being served out from Elasticache. So response times are going to be faster. Database scale is good. You can do more with less. And you're going to lower your AWS costs. This is very typical for an e-commerce, public-facing application, okay? The average query time, I'm sorry I didn't pause it, but probably went down 4 times. Yes?
So let's say for application, this is Aurora and the cache and very important we want to get this one. So you say only 2% give to Aurora, everything is a cache. So cache is very important. For you, the site is very important. You have to decide well ahead. Otherwise, they will change whatever the site of this. So how to handle that one? Because right now we don't know how we are going. So suddenly, cache is very important and we have to change it.
Okay, so the question is basically capacity planning for sizing. So there's a lot of angles to that. So basically what we're gonna do, obviously if we're gonna cache 90% of the traffic, you're gonna do a lot more, you can do a lot more with less with RDS size. So you need to determine whether or not you can downscale or you wanna do more with processing for other purposes. For the Heimdal itself, we take very little footprint. Just to give you an idea, for CPU utilization, it's in the single digits. For the memory, the cache size would probably be in the megabyte range, about 250 to half a gig for cache size. Obviously, it will vary based on application workload, okay? But on the average for a public-facing e-commerce type of site, we take very little memory, half a gig the most, okay? So capacity planning is something that you would have to decide. It's not a one-size-fits-all type of thing, and we can help you with that. Yes. Okay, so the question is, if you had Elasticache, could you use it for, let's say, entity level caching, application level caching, and SQL level caching? The answer is yes. So what you're doing is, if you have Elasticache today, you're just expanding that to do query caching now. And then Heimdal is going to provide the logic for you. Okay, very simple. And if you're not getting the benefits, you pull out the database proxy, and away you go. It's completely transparent. Okay. I want to get a little bit into analytics because I think my time is up here. Real quick, I'm going to do an analyze, and I will have to end our session because I think you all would really like this. This provides really good analytics on client-side and server-side analytics, okay? This is great for the developer and the DBA because a lot of times due to confidentiality and whatever, there's a lot of processes in probably larger organizations to get this information from the database side. Now you have database side and client side information. Here, what we see is the database usage. So for this particular query, this represents 10% of the total database time. So this is an important query to optimize if you can. This is the cache hit rate is pretty nice. It's at 93%. So that's pretty good, okay? We show you the cache response time, the DB response time, and this is the weighted average between these two. And this is the query. Now, what's also nice for developers is we also provide the query plan. Okay? Do you guys like this? The query plan? So for developers, you guys have a very good view of client-side, server-side analytics to figure out, hey, what can I do to optimize my queries? Okay? So we have diagnosis and also cure as well. And with that, thank you for attending this session. And if you have any more questions, we do have a desk out there, a booth out there, and I'll be happy to answer any questions. Thank you.